Okay. Where are you watching from? You're welcome. Share the broadcast. Chemical equations. How to write chemical equations. Chemical equations. Tell me where you're watching from. We talk about chemical equations. Tell me where you're watching from. Okay, where are you watching from? We talk about something very important called chemical equations. This is your science tutor, Mr. Ruben Jofu. Okay, so tell me where you're watching from. As we begin talking about chemical equations, tell me where you're watching from. Where are you watching from? Share your location. We get started. Share your location. Where are you watching from? Share where are you watching from? Where are you watching from? We talk about chemical equations. Chemical equations. So tell us where you're watching from. Kitwe, okay. Tell us where you're watching from as we get started. Where are you watching from? This is under chemistry, chemical equations. Where are you watching from? As we begin to start talking about something very important that you must know. This is a part of chemistry, okay? You don't know this, you need to know this because this is part of chemistry. So just tell me where you're watching from as we begin to talk about what? Chemical equations. So where are you watching from as we talk about chemical equations? Share your location. Where are you watching from? Okay. Watching from Kitwe. Watching from Chidabombe. Okay. Kawata. Wow. Chilango. Chingola. Okay. This is nice. Chilanga. Okay. Alright. Hope you are all doing fine. Share the broadcast. Invite someone who is online. Invite your friend. This is a very important topic in chemistry that you must know. So invite someone. Just tell someone, oh, there is science there. We have started learning now. We want to talk about what? Chemical equations. These are very important. How to form what? Chemical equations. So you must know when you talk about something, chemical equations. So we are going to start now. You must know something when it comes about what? Chemical equations. Alright. Let's get started now. Hope you have invited. Hope you have shared the broadcast. We are about to talk about chemical equations now. Chemical equations, this is chemistry now. Okay. So when you hear the word chemical equations, these are equations that are formed in chemistry that they use. They are called what? Chemical equations. So I want to show you something about these chemical equations so that you must know something, okay? So they bring something like this. This is a chemical equation, right? So I want you to understand one thing. All chemical equations are formed when one or two compounds have reacted with what? With elements. So chemical equations are formed when there is a reaction of reactant that will produce what? Product. So it is something like this. So reactant, when reactant reacts, they'll produce the enzyme that indicates with the arrow, and here these are called what? They are called products. So there will be a reaction that will react, they are called reactants, and this arrow here, it shows now when the reactants have reacted to show the what? The products now. Okay, so let's get started now. This is a topic that is very important that you must know in what? In physics. So in chemistry. So let's talk about these reactions now. how are these reactions very important in chemistry? So they bring about a chemical change. When they are reacting, they bring about a what? A chemical change. So this is a periodic table. You must know something like this. You must know something like this. We were talking about chemical reactions, right? So you find a periodic table is like this, is it? A periodic table is like this. Okay. So something like this, yes. So when you go on the periodic table, these are group 1, these are group 2, group 3, yeah, going like that, group 4, group 5, group 6, group 7, and group 8, which are written as what? Group O. So this is a periodic table. Now, how are chemical equations going to be formed now? I want you to pay particular attention, okay, on these chemical equations, how they are going to be formed. So this side, these are metals, right? So apart from this, there's a zigzag line. This line going this side, these are non-metals. Okay, so I just want to show you something. These are non-metals, and this side, these are metals. So the reaction that is always formed, the reaction, chemical reactions, is that it's either a metal will react with a non-metal to form a what? A product. The reactants must react to form what? A product. So it's either a metal will react with a non-metal, it's either a compound will react with a metal, but to form something. So this is how the reactions they go about. So first pay attention. The example that I can give you is that you find in the metals here, you have magnesium. Magnesium is like this. Okay, so magnesium is like this. On the periodic table, it has 12 here and it has 24 up here. So how are you going to write the electronic configuration of magnesium? So the first shell is supposed to have 2 electrons. The second shell is supposed to have 8. So this is 10, it's supposed to be 12, right? So the last one is 2. So the outermost shell, the last shell, determines the valency of an element. So the last shell determines the valence of what? An element. So check here. So you say magnesium, metals, they have a positive charge. Non-metals, they have a negative charge. Because metals, they lose, and non-metals, they what? They gain. So magnesium, because the valency, the last shell has got 2, so it has a valence of 2 positive, right? So we are talking about chemical reactions. So we want to react magnesium, which is in solid form, plus oxide gas like this. So what are the products? So these two are what are called reactants. They are reacting. So when there is a chemical equation, it brings about change. So a metal, magnesium, is reacting with this and oxide. So magnesium is like this. It has a valence of what? 2 positive, right? But so it has a valence of 2 positive. What about oxygen? When you go on the periodic table, oxygen is 8 here, here is 16. So write the electronic configuration. The first shell must have 2. So for it to be 8, the other shell will have what? Will have 6. So that when you add 6 plus 2, you get 8. So how many electrons does oxygen needs for oxygen to become what? To become 8 stable. So you say oxygen needs 2 negative, right? So oxygen will have 2 negative like this. So you cross them. You cross these valences that are up. So it will be magnesium with the 2 for oxygen and oxygen with the 2 for magnesium. So these 2 and 2 will cancel. You remain with what? Magnesium oxide. So this is a reaction. When magnesium reacts with oxygen, it will form what? Magnesium oxide. This is how you form reaction as we are just starting. So this is how you form reaction. This is how you form reaction. So let me show you another one. There are a lot of reactions that we are going to talk about. So the other reaction that we can talk about here is that an acid, these are chemical reactions, an acid will react with a metal. So you find that this is a reaction where an acid will react with a metal. So when an acid reacts with a metal, it will form salt plus hydrogen gas. So how is the chemical equation going to be? So any acid, hydrochloric acid, an acid is the combination of hydrogen gas and the radical. So an acid is like this plus a metal. Give me any metal, so you can have what? Calcium here. So when this acid reacts with calcium, what is the end result going to be? What are the products? So how are you going to write a chemical equation in a equation that says that hydrochloric acid reacts with the calcium? So write the chemical equation. Write the chemical equation when hydrochloric acid reacts with what? Calcium. So before you write the chemical equation, know your reactants before you go to the product. What are you reacting? What are you reacting? So the question is saying hydrochloric acid reacts with what? Calcium. So before you write your chemical equation, what are you reacting? So this is very simple. Okay, so hydrochloric acid reacts with what? Calcium. So this is hydrochloric acid and this is calcium. So every time when an acid reacts with a metal, it will produce two things, a salt and hydrogen gas. So how do you write the product? These are reactants. How are you going to write the product? So a metal will replace hydrogen. A metal will replace hydrogen. So if a metal replaces hydrogen, there will be metal like this, metal chloride. But what is the valency of this calcium? So when you go on the periodic table, you find that calcium is like this. It has 20 here, here it has 40. So you draw the electronic configuration. So you say this is 20. You're supposed to split it. The first shell it must have 2. The second shell it must have 8. The third shell must have 8. For 8 to be 20, so what do you have? 2 plus 8, 10, plus this one, 18. So for it to be 20, you are remaining with what? You are remaining with 2. So calcium, because it's a metal, it is positive. This last number determines the valency of the element. Okay, so the last number, the last shell, determines the valency of the element. So calcium, because it's a metal, it has a positive, so it will be called 2 positive like this. So calcium has a valence of what? 2. So you say calcium has a valence of 2 positive. What about chlorine? On the periodic table, chlorine is like this. It has 17 here, here it has 35.5. So to write the electronic configuration, you only concentrate on the what? The electronic number here, the proton number. So for it to be 17, the first shell must have 2. The second shell must have 8. So this is 10. So for it to become 17, what are you left with? 7. So how many electrons does this need for it to be stable? 1 electron. And it's a non-metal, so it is negative. So it is going to be what? You are going to write a negative here. If you want, you can just write 1 negative, it is the same. So when you are drawing now the structure of the compound, you do this. The valences are here up. You cross them like this. You cross them like this. So this one will come for calcium, and chlorine will get the valence of calcium. Chlorine will get the valence of calcium. So this is 1. So it will be calcium chloride like this. You see? You see? It will be calcium chloride. So these are very simple. These are reactions that you must know. So this is going to be called what? Calcium chloride. And we are saying that an acid will react with a metal to form salt and hydrogen gas. So how is the salt going to be formed? So a salt is going to be formed when a metal replaces what? Hydrogen gas, the hydrogen in the what? In the acid. So every acid must be replaced by a metal, then you form a salt. So this metal has replaced hydrogen, which is this one. It will be calcium chloride. These two, because of the valency of calcium plus what's remaining? Hydrogen gas. Okay. This is what you do. This is what you do. Another example that I can give you is that the same acid, sulfuric acid, when sulfuric acid reacts with sodium, it will form a salt and hydrogen gas. When an acid reacts with a metal, it will form salt and hydrogen gas. So this metal will replace hydrogen here. So it will be called sodium 2 sulfate plus what's remaining? Hydrogen gas. How did you come up with this equation? So you come up with this, you say this, sodium, it has 11 and it has 23 on the periodic table. So you need to make this the electronic configuration. So it has 2 and it has 8. So this is 10. For it to become 11, you're remaining with what? With 1. So which means this shows the valency of sodium, that it has a valence of 1. Okay. Then this, because a metal will replace hydrogen, so you have this. Sulfate is a radical which has the valency of 2 what? Of 2. So it will be 2 negative like this. So this 2 for sulfate will come where a metal is, and this 1 for the metal will go where sulfate is. So it's going to be like this. Okay, hope you are following. I want to find the messages there. If you are behind, just type something there. I'm coming to see. If you are not getting something, if you are getting something, just write I'm following. If you're not following, just write I'm lost. So I can check, I repeat myself. Okay, so this is sodium. It has a valence of 1 positive. And sulfate, like this, it has a valence of 2. It's a radical. So how are you going to write the chemical equation? Is that the way you're going to cross them like this? The valency for sulfate will come to what? For sodium. The valence for sodium will go to what? To sulfate. So it will be sodium with a valency of sulfate, and sulfate with the valency of what? Of oxygen 1. So it will be just what? Sodium sulfate. So this is sodium sulfate. Then what is remaining? Hydrogen gas. Okay, let me check the comments now. Are you following? Are you following? Are you following? Who is lost? Are you following? Hope you are following. Are you following from this pace? Are you okay from this pace? Are you okay? Are you okay? Are you okay? Are you okay with this? Are you okay? I want to see. Okay. This is brilliant. Okay, check now. So, this is the reaction. We have said the first reaction is that a metal will react with an oxide to form a what? A metal oxide, right? This is how you form. We're talking about chemical equations. How to form chemical equation. So, they'll tell you that write the word equation. Write the word what? Write the word equation. So write the word equation. So to write the word equation of this hydrochloric acid reacting with what? So say write the word equation of this calcium chloride plus hydrogen gas. So these are the reactants and these are the what? Are the products. So to write the word equation, you're going to say this is hydrochloric acid. You say hydrochloric acid plus calcium, which will give you calcium chloride plus hydrogen gas. So this is the word equation. So that's the word equation that you are supposed to form. That's the word equation that you're supposed to form. So What if you have been given something like this? H3PO4 when it is reacting with this. So this is a reaction of an acid and a base that will form salt and water only. So I'm telling you about chemical equations now. So an acid that you have been given, H3PO4 plus NaOH, this is equals to, so how do you form the chemical equation now? So the metal must always replace the hydrogen of an acid. So the metal will replace the hydrogen of an acid. So which is going to be what? Metal and 3PO4 plus what are you left with? You have OH and you have the hydrogen which has been replaced, right? And the water. So this is the reaction, a chemical what? A chemical equation. So this is the chemical equation that has been formed. So this is the chemical equation that has been formed. Okay, so let's talk about just some more equations that I want you to understand today. So we are talking about chemical equations. We are talking about chemical equations. Chemical equations. Chemical equations. The other equation is that a metal will react with water to form metal hydroxide plus. So when a metal reacts with water, it will form a metal hydroxide plus what? Hydrogen gas. Hydrogen gas. So give me any metal. So any metal that we can write here, we can say sodium is a metal plus H2O. So when sodium has reacted with a metal, so this is how we react. This is how you form equations. When a metal has reacted with water, it says that a metal, when it reacts with water, it will form metal hydroxide plus what? Hydrogen gas. So what hydroxide are you going to form here? There are two hydrogens here. There's one oxygen and there's this. So there are two hydrogens in here, and this is a metal. So this metal will react with what? With this water to form metal hydroxide. So this is hydroxide, OH. So the metal will react with one of the what? Hydroxide here with the water to form metal hydroxide plus what will remain? Hydrogen gas. So when a metal reacts with water, it will form metal hydroxide plus hydrogen gas. Okay. Are you following? I want to check if you are following in the comments. In the comments. Are you following? Are you following? I want to see if you are following. Write something if you are following. I want to be sure if you are following. Are you following? Are you following? Is it okay? Or I repeat it. This is when I'm seeing the comment. Okay. So let me just repeat it once again. So these are chemical equations. Let me show you now how you write them nicely. So pay particular attention. Pay particular attention. So I'm saying when you're reacting, you need to identify your reactants and the what? And the product. So if you know the reactant, the product won't be difficult. So the first reaction is that, let me say a metal, magnesium. This is the wet equation. Magnesium plus water, it will form magnesium oxide plus hydrogen gas. So how are you going to write now in symbols now, in chemical equation now? See, magnesium has a symbol of this on the periodic table, right? Plus water is H2O. So how are you going to know your product? So when a metal has reacted with water, it will form metal hydroxide plus hydrogen gas. So when a metal has reacted with what? With water, it will form a metal hydroxide or a metal oxide and what? Hydrogen gas. So check here. This is magnesium. The water, it has like this, two hydrogens. There are two hydrogens here. So magnesium will react with this. Magnesium will react with this to form a what? To form a metal oxide or metal hydroxide plus hydrogen gas. So how do you react them? Magnesium will react with what? This, or what will remain with? Hydrogen gas. So if you can see this, when you add this and this, you get water. This is for this. Okay. Okay. Yes. So another one I said an acid plus a metal, it will form salt plus hydrogen gas. So any acid, hydrochloric acid, when it reacts with a metal, sodium, what will be the product? So I said that when you're reacting like this, you know your what? Your reactant. Know your reactant first, then before you go to what? The product. So this metal will replace what? The hydrogen here. The metal will replace the hydrogen, which will form metal chloride plus what's remaining? Hydrogen gas. Okay. Okay. Oh, you're getting it now. Wonderful. Wow. Wow, this is wonderful. This is wonderful. I'm loving it. If you're getting it, I'm so happy. I'm so happy if you're getting it. So these are reactions. Another reaction that I can give you when sodium has reacted with chloride. So on the periodic table, this is a metal, this is a non-metal. When they have reacted, they will form sodium chloride. Why sodium chloride? Because sodium on the periodic table, it is in group 1, so it has a valency of 1. Metals in group 1, they have the valence of 1. Elements in group 2, they have the valency of 2. Elements in group 3, they have the valency of 3. So metals, they have the valence of 1, 2, and 3 in their outermost shell. So sodium is in group 1, so it has a valence of 1, and it's a metal, so it is positive. Chlorine is in group 7, so it needs 1 electron for it to be 8. So it has a valence of what? Of 1, negative. So these will neutralize each other. They'll form sodium chloride. Okay. Another one, magnesium plus magnesium plus chlorine, like this. So magnesium, these are the reactants. What are the products? So magnesium will react with this. So magnesium is in group 2, so it has a valence of 2. Then chlorine, it needs only 1 electron for it to be stable, so it has a 1 negative here. So these will cross. You share the valences, they cross. When you're writing the chemical equation, the valences, they cross. You get the valence of this one, you bring it down. The valence of this one, you bring it down, then you form the chemical equation. So magnesium will get the valence of what? Chlorine 1. Then chlorine will get the valence of magnesium 2. So this is 1, so you can just write magnesium chloride 2, like this. This is how you write chemical equations. So this is how you write chemical equations. That's how you come up with chemical equations. Okay. This is how you come up with chemical equations. That's how you write chemical equations. Alright, so let's talk about state symbols now. Because we are just introducing chemical equations, let's talk about state symbols now. State symbols. State symbols, state symbols, state symbols. You need to know about state symbols now. So these state symbols are very important. They'll say write a state symbol. So the next time we meet, we will talk about how to balance chemical equations. So we say state symbols. State symbols. State symbols. So state symbol, there is solid, there's liquid, there's gas, and there's aqueous. So solid, the state symbol is S. Liquid, the state symbol is what? Liquid. Gas, the state symbol is G, small g. Aqueous, the state symbol is what? AQ, aqueous, like this. So these are the state symbols. Where do you put solid? You put solid when the element is in solid form. When the element is in solid form, you put this solid. When it is in what? Insoluble. It does not dissolve in water. The other one, liquid, you put when it is a liquid, they'll say water, H2O, for example, it has a state symbol of what? Liquid. Metals here, I can say magnesium, it has a state symbol of solid. A gas, let me say hydrogen. Hydrogen is a gas, so the state symbol is G. Aqueous, an acid is an aqueous. Any acid is an aqueous. So hydrochloric acid is the acid, so it is in aqueous form. So let's write a chemical equation and let's write the state symbols there. So you start hydrochloric acid plus, when it's reacted with sodium, which is a metal. So an acid is always in aqueous form. A metal is always in solid form because it is a metal. So when this reacts, this will replace the hydrogen, right? To form sodium chloride plus hydrogen gas. So this sodium chloride, it is in aqueous form. Then the gas, it is in gas form. Okay. So these are how you form the state symbols, how you write the state symbols. But there are some rules that you must know. There are some rules that you must know in writing state symbols. The rules that will state that all sulfate, they are aqueous, all sulfate are soluble. So this is how it is going to be. Okay, so for now, we have the online group. We have the online class that takes place every time. So we have the online class. So I want you, if you haven't yet registered to the April online class, we have topics in chemistry such as periodic table. We want to talk about periodic table. These are the topics. There is salts. We're talking about salts. Yes, there are gases. Talking about gases, and there is more concepts. So these are what we want to do in April. So there is the online class that is going on now. So if you haven't yet registered for April, please register. And how do you do it? Just put your number there down and I'll call you personally. I'll tell you how to do it. And the fees is just 65 kwacha per month. Science, both chemistry and physics. It is just 65 kwacha per month. And it's both chemistry and physics, and don't be left out. This is not the chance that you must miss. We talk about the periodic table. We talk about salts, gases. It is the online lesson. So, if you haven't yet registered, put your numbers there. Put your numbers. I'll call you. Then I'll make you to join the group. You join the group. Then you will learn with them. You will learn with others because they are joining. So join before the space has finished. Join before the space has finished. In this, we'll talk about more reactions. We have more reactions, chemical equations to talk about. So just make sure if you're interested in learning more of these, the periodic table, chemical equations, you have challenges. This is your science tutor, Mr. Ruben Jovo, and I promise you to help you and to get distinction in science. Okay, so just drop your numbers there, drop your lines, we'll call you, we'll tell you how it is. The amount is saying here is just 65 kwacha. The fee is 65 kwacha for both chemistry and physics per month. Where you'll be sent videos on YouTube, you learn, we teach you like I am teaching you right now. So just make sure you join and you are not left out. So take care of yourself. This is your science tutor, Mr. Ruben Jovu. Hope to see you again in the other video. Bye bye and take care. Okay, see you in comments now.